We have contestant 1, Angela Shipp from Omaha, Nebraska, attending Nebraska University and majoring in corn husking. Contestant 2 is Sara Carter from Toronto, and contestant 3 is Lindsey Perryman from Arkansas State Technical Institute. Let's get it on the go. All right, contestants. Question 1. Could you please give me a brief overview of how gravity and motion of the planets were viewed historically before Newton? Include the views of Aristotle, Galileo, and Kepler.
Before Newton, gravity and motion of planets did not have anything to do with each other. It was believed that the planets moved as dots or motes upon crystal spheres centered about the Earth. Aristotle believed that the movement of planets was based upon their comparison of the 4 elements. For example, Earth was the heaviest element, so Aristotle believed that it would move towards the center of the universe. He also believed that the sun, moon, and stars moved on an unchanging circular motion. Regarding gravity, Aristotle believed that all objects moved toward their natural place. Galileo believed that the moons orbited the planets and all of the planets orbited the sun. He also discovered that free-falling bodies, heavy or light, have the same constant acceleration due to gravity. Kepler's laws of planetary motion are: the orbit of every planet is an ellipse with the sun at one of the two. One joining a planet, and the sun sweeps out equal areas during the equal intervals of time. The square of the orbital period of a planet is directly proportional to the cube of the semi-major axis in its orbit. And Kepler did not have a gravitational theory.
You're such a nerd.
Question 2. Generally describe the life and times of Isaac Newton, including his personal life. Describe his major scientific contributions, including his contribution to the theory of gravity.
Newton's personal life. He was born at Woolsthorpe. He attended school in Grantham in Lincolnshire. He attended Cambridge University in 1661. He was elected a Fellow of Trinity College in 1667 and Lucasian Professor of Mathematics in 1669. His contributions to science were: first, he published an incomplete theory of chemical force. He wrote many manuscripts on alchemy and chemistry. And his contributions to the theory of gravity were his 3 laws of motion.
Question 3. What was the major contribution of Henry Cavendish to the universal law of gravitation? Describe his primary experiment.
Henry Cavendish's major contribution to the universal law of gravitation is he weighed the Earth. His experiment was enclosed in a small room to block out air currents. Lead weights were suspended on a torsion pendulum, a bar with weights at each end that were suspended on a wire.
What role does the equivalence of the inertial and gravitational properties of mass play in the development of general relativity?
The equivalent plays a crucial role. The coordinate systems are accelerating with respect to each other. In one system, all of the objects at rest seem to be accelerating because the objects next to them are accelerating.
I knew that.
Did you really?
Question 5. How does gravity correspond to the bending of space-time fabric?
Gravity corresponds to the bending of space-time fabric in that the gravitational pull of space masses bend the space-time fabric as they pass through the atmosphere of said masses. Gravity is the negative slope in space-time fabric. The deeper the slope is, the stronger the gravity is.
Question 6. What is the Schwarzschild radius?
A radius described for a body of a given mass and proportional to the mass. Like a black hole, if the body is smaller than the radius, the gravitational force is strong enough to not let anything escape.
Question 7. What are black holes and are they real?
A black hole is a region of space having a gravitational field so intense that no matter or radiation can escape, including light. And yes, they're real.
Question 8. How does gravity bend light? And what is gravitational lensing?
Newton believed light curves when it went near to and past astronomical bodies. A gravitational lens is formed when the light from a very distant bright source is bent around a massive object between the source and observer.
Question 9. What are wormholes and are they real?
Too late.
A wormhole is a hypothetical topological feature of space-time that would be, fundamentally, a shortcut through space-time. It is like a tunnel from one point in space to another point. No one is sure if they are real or not, but I will prove it one day.
Question 10. Why is it called the general theory of relativity and not the general hypothesis of relativity? Distinguish between hypothesis, theory, and law as used in physics. And what predictions of general relativity have been verified, if any?
I don't know it. I don't know
A
it.
hypothesis changes to a theory when empirical evidence backs it up.
That was the last
Every
one.
experiment done over the last 90 years has supported general reactivity. Not one experiment has challenged it. Indeed, accurate GPS device would work unless the effects of general relativity were not factored into their clocks. So, in effect, every GPS device in the world is an experiment that supports GR.
And the winner is